This is Higher Paper 2, Section 2. For the first question in this section, we've got a compound interest question. First step whenever you're doing compound interest is we need to try and change the percentage increase that's happening into a decimal. The way that I would do this is think that whenever we do a percentage question, we are always imagining that we're starting on 100%. If we add the 1.7% on that we are getting for interest, this would give us 101.7%. We can change this into a decimal multiplier simply by dividing it by 100. So to change this into a decimal, we would get 1.017. In order to find out how much you would have after 1 year, we would multiply 1,800 by 1.017. To find out what it would be after 2 years, we would multiply the answer to this by 1.017. And then for 3 years, I would times the answer to all of this, again, by 1.017. So in fact, what we can do is simplify and say this is the same as 1,800 multiplied by 1.017 to the power of 3. This gives us £1,893.36944. Obviously we want this to be in a correct version for money, so this would become, with a pound sign at the front, 1893.37. The next topic is also linked to this question. So this time, Mr. Britton invests £1,800 for 3 years, but here the percentage is changing each year. We can use the exact same idea as before. So an increase of 1.7% would give us 101.7, which would be 1.017 as a percent. So using the same idea, 1.8% would be 1.018, and then 2.1% would be 1.021. So we can use this and simply multiply our starting amount of 1,800 by 1.017 for the end of the first year, multiply that by 1.018 for the end of the second year, and multiply that by 1.021 for the end of the third year. This gives us an answer of £1,902.69 when rounded to 2 decimal places. The next topic is all to do with volumes of a sphere. We've got here the formula for the volume of a sphere. Now that might be given to you in the exam, but it does not have to be. So you may be expected to remember that. Probably a good idea to try and do your best to memorise it just in case for this mock. In order to find the volume of these spheres then, all we would do is substitute in r equals 5 for this one into our little formula up here. So I would do 4/3 times pi times 5 cubed, which if you type into your calculator gives us an answer of 523.598. Same for this one, 4/3 times pi, but this time because the radius is 8, we've got 8 cubed. Again, type it into your calculator, 2144.66. Notice I'm putting at least 2 or 3 numbers after the decimal point in each case. I would suggest you do the same. For the third one, exact same idea, 4/3 times pi times 12 cubed, and this gives us 7,238.229. The next section here is all about density. So this suggests that there's going to be some sort of follow-on question on the sphere topic. So all of these spheres are made out of gold. The density of gold is 5.8 grams. We need to remember that the formula for density is mass divided by volume. we are being asked to find the mass. So if I rearrange this formula to make m the subject, I would have to times by v to undo the divide by v here, therefore giving me that mass is equal to density times volume. So all I'm going to need to do is multiply the 3 volumes that I got here by the density, which is 5.8. Now at this point we have actually missed off just one very quick thing in terms of units. Don't forget, like I did here, to put centimetres cubed at the end of each of these. So timesing each of these by 5.8 will give us the total mass. Now if you look, the density is in the units of grams per centimetres cubed, so we are going to get answers that also come out as grams. Timesing by 5.8 here gives us an answer of 3036.87, obviously grams. Times this one by 5.8, again, the density that were given earlier in the question. This would give us an answer of 12,439.03. Again, making sure that I leave at least a couple of numbers after the decimal point. And then multiplying the last one by 5.8. So this sphere would have a total mass of 41,981.73 grams. The next topic is not obvious straight away as to what subject we are looking at. So let's have a look and see what information we can put onto the diagram. So here it is telling us that the area of the rectangle is 14 centimetres squared. At this point we completely ignore the fact that that line is there splitting this into triangles. So if it tells me that that's 14 altogether, I bring in the fact that I know the area for a rectangle is length times width. So obviously if the area is 14, we would need this side here to be 2. 2 times 7 equals 14. If we now ignore the rest of this triangle up here, what we have is a right angle triangle where we know 2 sides and we're asked for 1 angle inside. Therefore we're going to use trigonometry. In order to do this, we need to label up the sides that we know. So here is the angle that we're given, or that we are going to find. So this is the adjacent side. Here we have the opposite. So we've got opposite and adjacent, therefore we are going to be using tan. Now whenever we are finding an angle using trigonometry, we are always going to use tan to the minus 1. You'll have to use either the shift or the second function button on your calculator in order to get the little minus 1. Inside the bracket, we then do opposite divided by adjacent, because this is the order that it appears in SOHCAHTOA. O, then A. If I type this into my calculator, I should get an answer of 74.1. Just make sure that your calculator says at the top of the screen degrees or deg. If it says radians, which is RAD, or grad, you'll need to change the settings on your calculators to give degrees instead. We've got one more example of that question. So here we've got 40 centimetres squared as the area. So if this side is 10, this side is going to have to be 4, because 4 times 10 gives us 40. Now ignoring the rest of the shape and focusing just on the triangle, again we have opposite and adjacent, so we are using tan again. And whenever you're finding an angle using trigonometry, as before, we're going to do tan to the minus 1. The minus 1 bit is the bit that we do every time for angles. Inside the brackets, we do opposite divided by adjacent. So here, 4 over 10. If I type that into my calculator, that gives us an answer of 21.8 degrees. Just make sure when you're doing these questions that you actually put a bracket at the end of the 10, because sometimes it will not assume this on the calculator and it could give you the wrong answer.